Hey guys, hope you're well. So we'll finish off this unit with looking at how trig equations can be used to model real-life situations. Before we start, just a reminder that this is the general form of a trig function. It could be a sine or a cosine, but remember what these terms mean. I hope you remember what these terms mean. A is the amplitude, B is the period, C is the left and right shift, D is up and down. So for examples 1 and 2, which are coming up, we're going to construct a sinusoidal function. Sinusoidal function means it looks like a sine graph, right? A sinusoidal function is just a periodic function that is repeating. That's just what that means. With the provided information, so there's information that's given in the question, we use it to draw the function and then solve the equation for the requested values. After setting up an equation, we can plug in values to solve for what is wanted. This is what is meant by that. Now, from on the first look, this is going to look ridiculous or outrageous. You're going to think, how can I get any information out of this? But just break it down one at a time. Just remember that our guiding idea is this equation. This is what's guiding us. So we'll just try to look at the equation and try to pick out as many of these terms as we can. Yeah. So outside temperatures over the course of a day, and let's copy this equation. Copy the equation. Paste. Okay. It says the outside temperatures over the course of a day can be modeled as a sinusoidal function. That's nice. That means it's repeating. Suppose the high temperature of 84 degrees Fahrenheit. Now it's starting to give us information. The high temperature. We know if it's a sinusoidal function, it's supposed to look like this, right? If it looks like that, repeating, it has what you would call a midline. This is the midline. And I hope you remember that this midline is the value of D. This midline, if this midline is 0, that means there's no vertical or horizontal shift, right? Sorry, that means there's no vertical upwards or downwards shift if this was 0. But if this was any value, that means that's how far off of the 0 that has been shifted. Anyways, back to the 84. This 84 is telling us that the highest point on this graph, is going to be 84. So this point corresponds to a y value of 84, right? That occurs at 6 p.m. 6 p.m. is when that occurs. The other piece of information that we're given is over the course of the day. Over the course of the day. A day is 24 hours. So over the course of the day, it's a sinusoidal function. Since the day is 24 hours and the outside temperatures over the course of the day, that means the period for this function is 1 day. And also remember, when we're figuring out the period for these functions, remember this equation, period is equal to 2 pi over b. Now it's known that the period is 1 day because these temperatures are changing over the course of 1 day. So 24 hours is equal to 2 pi over b. If I solve for b, I'll end up with b is equal to 2 pi over 24, which is the same thing as pi over 12. So I know what b is. B is pi over 12. Okay, let's see what else I can get from this equation. I mean, from the information that has been given. B is pi over 12. Good. The high temperature is 84. Okay. That occurs at 6 p.m. Okay, that's going to help me at some point. But then it says the average temperature is 70. Now this is telling you what the midline is. Because again, if you think about the sine graph, even if it was a cosine graph, the average, if I try to find the average of this point and this point, or the highest point and the lowest point, the average of all the highest points and all the lowest points is just going to always be that straight line that's cutting it in half. It's like the midway between the highest and lowest points. That's what this average is, right? So it's telling me that this midline is at 70. And remember what I said about the midline earlier. The midline is the value of y for which the graph has been shifted up or down. If this is at 70, that means I have a 0 somewhere down here. And this graph, which was supposed to begin at 0, which was supposed to have its midline at 0, now has its midline at 70. So that means that that 70 is my d value, right? That's my d value. Okay, so I know what the midline is. I know what the highest value is because the highest temperature is 84. That's 70, this is 84. That means I can figure out what the amplitude is, because the amplitude is simply how high or how low it goes above or below the midline. So I can see that it goes above the midline 14 degrees Fahrenheit. So my A is 14, my B is 5 or 12, my D is 70. I just need to figure out what C is. Now to figure out C, I'm going to use a substitution here. This part of the question tells me that the high temperature of 84 degrees happens at 6 p.m. This is the last piece of information I had to use. 6 p.m. If you think of the day as a 24-hour period, right, from midnight, which I'm calling 0, to the next midnight, which is after 24 hours, this is going to be midday, which is 12 p.m. 6 p.m. is going to be somewhere here. 6 p.m. is going to be in the upper half of the day. This is 6 a.m. So 6 p.m., just figure out how many hours away from the beginning is this. 6 p.m. is a whole 18 hours away from when the day started. So after 18 hours, that's when the high temperature happens, right? This is giving me a coordinate. It's giving me an x value, which is 18 hours, and it's giving me a y value, which is 84, right? So I'm going to just substitute this coordinate, x value and y value, into this equation, and then the only unknown that I'll have will be c. So let's create space by taking this out. I'm going to substitute my y value as 84. The amplitude is 14. This is sine. B is pi over 12. X minus c, which I'm looking for, plus d, which I know is 70. So if I subtract 70 both sides, then I'll have 14 on this side is equal to 14 sine pi over 12 x minus c. Now, I'm trying to solve for c. I'll first divide by 14, so I have 1 is equal to sine pi over 12 x minus c. Because this is basically sine pi over 12 x minus c is equal to 1. If I want to isolate this component, the angle, if I want to isolate the angle, I'm going to take the inverse sine on both sides. So the angle this side, I'm just basically solving, of x minus c is equal to the inverse sine of 1. I hope you guys remember that the inverse sine of 1 is 90, which is pi over 2. On this side I have pi over 12. I have not substituted for the x value this whole time. I should have done that earlier, but it doesn't matter. It's 18 minus c. Now when I solve this for c, you will find that, just create more space. If I solve that for c, I will have multiply by 12 here, multiply by 12, divide by pi, divide by pi. So I'll have pi into 18 minus c is equal to 6 pi. Divide by pi, divide by pi. I'm doing this very slowly, but you can do it much faster than this. You don't have to go through all of this. repetitive algebra. You could have just gone straight from here to the final answer. 18 minus c is equal to 6, and therefore that means that c is equal to 12. So I have found c as well. C is 12. Now I have all the information that I need for this question. I have all the information that I need for this question. The only thing I need to figure out now is the question that they asked me. Find the temperature to the nearest degree at 7 a.m. Find the temperature to the nearest degree at 7 a.m. So they've told me the time. I need to figure out how many hours away from the beginning that is. And I just substitute that time into the equation and I'll get the temperature. This is just a recap. The A value from that equation was 14. B is pi over 12. C, we solved for it as 12. And then D is 70. Now I can substitute to solve this portion of the question. Find the temperature to the nearest degree at 7 a.m. I just substitute for the time. 7 a.m. is 7 hours from the beginning. So I just substitute for x as 7 hours. So that's 14 sine pi over 12, open brackets, 7 minus 12, close brackets, plus 70. And then whatever this gives me is the temperature. That's 14 sine negative pi over 12 times 7 minus 12 is negative 5, so that's going to be negative 5 pi over 12, and then finally plus 70. Sine of negative 5 pi over 12, you guys can figure that out, and then do the algebra. Whatever you get, if it's right, it's the right. If it's the right answer, is the answer. Is your temperature in degrees Fahrenheit? Let's look at another example. A Ferris wheel is 45 meters in diameter and boarded from a platform that is 1 meter above the ground. So let me paste this thing again, because this is what we're going to be trying to figure out. Remember, this could be a cosine or sine, right? This could be a positive or negative, depending on the circumstances in the question. In this previous question, this was positive because it doesn't specify that the high temperature begins at the lowest, either time or displacement or something. But in some questions, if you had something that began with its highest value when time was equal to 0, then you would know that that's calling for a cosine graph. Or if something began with its lowest value at the beginning, again you would know that's a cosine graph. That's why I remember to say cosine here, because I looked ahead and I know this is a cosine graph. Okay, so let's prove me right. It says the wheel is 45 meters in diameter, so that means its radius is 22.5, and is boarded from a platform that is 1 meter above the ground. Let me try to draw a sketch of this thing. This is my Ferris wheel, perfect circle. Yay. And it's 45 meters in diameter, so it's a radius of 22.5. And it says that the boarding platform is 1 meter above the ground. So there's a boarding platform. Let me try to draw a boarding platform. Something like that. Is 1 meter above the ground. So that means this is 1 meter, right? Although it's a very terrible sketch. And this is 22.5 meters, right? And another 22.5 up here. This is my midline. Okay. So now when this Ferris wheel starts turning, like this, the position of someone who is on that Ferris wheel, the position of that someone is, if you're looking at it from, say, this angle here, it will just look like this person is just going up and down, right? And the physics people will realize this better. Other physics will identify with this better. The position of that person will just look as if they're going up and down, and up and down if you're viewing them from here. And if you try to draw a position versus time graph for them, it will look just something like that. It will be repetitive, right? It doesn't have to be sine or cosine. This beginning of the graph just tells me where the person began. If it starts spinning when at the loading position, then that graph will start at the bottom, right? And if it starts spinning at the top position, which is impossible because you're not going to fly to the top of the machine, then it would be a cosine graph that begins from the top. So yeah, that's just to help you see the situation before we start to deal with it. Okay, so it's saying that the 6 o'clock position of the Ferris wheel on the Ferris wheel is level with the loading platform. The 6 o'clock position. So basically, what would have been this position, the 6 o'clock, where it would start spinning, is level with the boarding platform. That's telling me that this is where that thing is going to start spinning at. So that's how I know that it's going to be cosine graph. It's going to be negative because it will start from the bottom, and the position of the person will go up, the position of the person will come back down. The person will go up, the person will come back down. This is according to time. But if time was not passing, then this thing would have just been going like that. Like that. Yep. Okay. What do we have? The wheel completes 1 revolution in 10 minutes. 1 revolution in 10 minutes. That means that my period is 10 minutes. And I hope you remember that period is something as 2 pi over b. So if I solve for b, you can see that I'll have b as pi over 5. So I know what b is. That's pi over 5. Okay. How many minutes of the ride are spent higher than 27 meters above the ground? Let's see if I can find other information like amplitude, like B or C. So since this is where it starts, I mean the ground level is here. Ground level is here, and that will be the level 0, the ground level, right? Going upwards, I have 1. That is where the platform starts from, the boarding platform is. Then I have this position. Since it has a radius of 22.5, and this is already 1 meter, this position is going to be 23.5 meters. And that 23.5, I hope you can see that that is the midline. That is the midline of my sinusoidal graph, or my repetitive graph that will come out of this expression. So this midline, remember the midline is your d value. So my d value is 23.5. How high above it goes the midline, how high above the midline it goes, or how low below the midline it goes, is your amplitude. So since the radius is 22.5, it's going to go 22.5 above the midline. So that's going to be to a position of 46.5. That tells me that my amplitude is 22.5, right? So I have amplitude, I have the nature of the function, I have b, I have d, I just need to find c. So let's try to find c. Let's try to find c. If I try to write, before I find c, if I try to write my equation according to the information that I already have, if I try to use that to write the equation, then this is the equation I'll have, that h is equal to negative 22.5 cosine pi over 5 t minus c plus 23.5. That's just substituting in the information I have here. This is a negative cosine, so that would be negative 22.5 cosine pi over 5 x minus c plus d, which is 23.5. I can use that to find c. I can use that to find c because it tells me that the 6 o'clock position of the Ferris wheel is level with the loading platform. So the 6 o'clock position of my Ferris wheel, which is this one here, is level with the loading platform. That means when my height is 1, right, what is my displacement? My displacement is 0. So when I substitute that into this expression, I should be able to get the value of C. When you do that, you get C is equal to 0. Let's see how we get C is equal to 0. At the beginning, before you start to move, right, a single person would be at a height. The height of the person before they start to move would be just 1 meter because they are on the loading platform. They just sat on the chair that's at the position of the loading platform. When the Ferris wheel is like you come, you get into the platform, you walk onto the seat. That's time equals 0, right? So substituting time is equal to 0 and height is equal to 1. I have 1 is equal to negative 22.5 cosine pi over 5, 0 minus C plus 23.5. Now I need to solve for C, so I'll take 23.5 off both sides. 23. So on the left I'll have negative 22.5 equals negative 22.5 cosine pi over 5 times negative C. Negative 22.5, negative 22.5, that divides out and I end up with 1 is equal to cosine negative pi over 5 times C, but you know cosine is an even function. This is the same thing as cosine pi over 5C is equal to 1. Now I need to find the inverse cosine of 1. The inverse cosine of 1 is 0. So pi over 5 times C is equal to 0, which means that C is equal to 0. That's how we find that C is 0. We have found A, B, C, and D, so we can write our equation. After writing our equation, we can use that equation to solve for the question that was asked. How many minutes of the ride are spent higher than 27 meters above the ground? So the height is 27 meters. Substitute for 22.5 cosine pi over 5. I'm finding T plus 23.5. So I'll subtract 23.5, subtract 23.5. 27 minus 23.5 is 3.5 is equal to negative 22.5 cosine pi over 5 t. So solving for this, create space. Okay. I have 3.5 divided by 22.5 is equal to cosine pi over 5t. Now I can use a calculator to figure out what t is, and when I find t, I need to divide it by pi over 5 so that I find the values of the time. What am I saying? To find t alone, I would need to get the inverse cosine of negative 3.5 divided by 22.5. That would be equal to pi over 5 times t, right? So once I get this, the value of this, you can use a calculator to figure this out. I'll have pi over 5t is equal to that number, right, that you get from using the calculator, and then t alone will be 5 over pi times that number. Yeah, try to make sure you get a positive answer for this inverse cosine, and it will give you a positive answer if you use your calculator. Okay, so the other thing we'll talk about is simple harmonic motion. Simple harmonic motion is basically repeating motion or periodic motion. It's motion that repeats or is periodic. And since we've talked about periodic functions, which are graphs that repeat, then it's only fitting that we talk about simple harmonic motion, which is a naturally occurring phenomenon in so many situations. When you're on a swinging on your swing through small angles of displacement, you're executing simple harmonic motion. If a car is going over some bumps and then it like goes up and down, this happens every morning when you're coming to school probably, that's harmonic motion. it's damped, which we'll also talk about, but it's still harmonic motion. If you have a spring that is like those slinkies that you can drop and it keeps bobbing up and down, that's simple harmonic motion. So trig functions, trig graphs especially, or trig equations can be used to model simple harmonic motion. For simple harmonic motion, the equation for the motion is simply d, where d is displacement, is equal to amplitude cosine omega t. Omega is called angular speed. Angular speed, simply the speed at which the angle is changing, and t is the time. So it's either a cosine or a sine, depending on the nature of the motion. And d is the displacement, a is amplitude. The period can be calculated by finding 2 pi over omega. I hope you remember that previously period was 2 pi over b, so kind of carrying forward that same idea. The period will be 2 pi over omega instead of b. And the frequency is the inverse of the period, because frequency is how many oscillations or cycles are completed in 1 second or 1 unit of time, and frequency period is simply how long it takes to complete 1 cycle. So once you have period, you just find its inverse or its reciprocal. Its reciprocal. That gives you the frequency, and once you have frequency, same thing, its reciprocal will be period. Example: the displacement in centimeters of mass suspended by a spring is modeled by this function, where t is measured in seconds. Find the amplitude, period, and frequency of this displacement. So, comparing this to the equation a sine omega t, I can clearly see that a is 11. A is 11. I can see that omega is 12 pi. Oops. I can see that omega is 12 pi. And I hope you see that omega is whatever expression is coming before the t, because this equation was clear, a sine omega t. So whatever kind of expression or values or figures are before the variable, which is t, that's what your omega is. So here 12 pi is before the variable, so that has to be my omega. Sorry about that. 12 pi is my omega. Okay, so after finding the omega, I can find the amplitude. I know the amplitude is 11. I can find the period. I know period is 2 pi over omega, which will just be 2 pi over 12 pi, which will be 1 over 6. And the frequency is the reciprocal of the period, 1 over t. So that will be 6 over 1, which is 6. So that means 6 cycles are completed in 1 second. And this means it takes 1/6 of a second to complete 1 cycle. Damped harmonic motion is, like I talked about earlier, that when your car is bringing you to school in the morning, it's going over bumps, but cars are prevented from executing simple harmonic motion, because if they executed simple harmonic motion, your car would never stop bouncing. From the moment it hit that hole, it just keep bouncing and bouncing and bouncing, and that would be very uncomfortable. So engineers figured out a way of damping the oscillations. Damping the oscillations meaning that the preceding cycle has less amplitude than the initial cycle. And as time goes on, the amplitude goes down. I hope you can see the amplitude is going down in this graph up to when the amplitude is 0. Obviously, in cars, they want to reduce the amplitude as quickly as possible. That's why you have shock absorbers. That as soon as you hit this hole, the springs are there, yes, but there's also something to absorb that shock, such that the amplitude goes down from whatever caused, from however deep that hole was, to 0 immediately for comfortable driving. So the equation is the same, except for this little factor that's added, this little portion of the equation that's added, And in that portion of the equation, oh, by the way, write this on your notepad. In that portion of the equation, C is called the damping factor. C is called the damping factor. Everything else is the same. A is the initial displacement, and 2 pi over omega is the period. So in an equation like this, it's the spring is pulled 7 centimeters down from the equilibrium and released. That tells you that the amplitude is 7 centimeters. Because it's pulled from equilibrium, the amplitude decreases by 11%, so that means your C value is 0.11. If it had said increases to 11%, then the C value would have been 100 minus 11. But since it decreases by 11%, then it's just that value each second. The spring oscillates 20 times each second. That means that the frequency is 20. If the frequency is 20, the period is 1 over 20, and we know that period is 2 pi over omega, right? So if I want to figure out what omega is from this, omega will be 2 pi times 20, which is 40 pi. They want me to find the function that models the distance at the end of the spring is from equilibrium in terms of t since the spring was released. So I'm just going to use any of these two ways. In terms of the distance d, the end of the spring is from equilibrium. The end of the spring is from equilibrium. It's pulled 7 down from equilibrium. Alright, so that has to be a negative cosine function, because if this is equilibrium, it's pulled down from equilibrium and then released, and that's when it stops to do its motion. So that's going to be a negative cosine function. I'll be using this one over here, and I'll just stick a negative in front of the a. So my function is going to be negative a, which is 7, e to the negative 0.11, because c is 0.11, t cosine omega is 40 pi t. Yeah, so there you have it. I know you have questions, so I'll be waiting.